Hello everyone, so I am back with the third video of the video series on class 9 science motion, and in this video we are going to talk about speed versus velocity. A very important concept. Many a times we think that speed and velocity are just the same, but they are not. So what exactly is speed? Let's understand.
What is speed? It is the rate at which an object covers distance. So speed, as I mentioned in the previous slide, that it is a scalar quantity. That means in order to define speed, only magnitude is enough. If I say that there is a boy who runs at a speed of 2 kilometers per hour. So I do not really need to mention any direction, that in which direction he runs. Just the magnitude is enough to describe speed. So speed will tell us how fast or how slow an object moves. So how do we mathematically calculate speed? It is the path length divided by time taken, right? So speed is equal to the total distance covered divided by time taken. So speed is a scalar quantity, so it is dependent on the scalar quantity path length. So speed is equal to path length by time taken. And what is the SI unit for speed? Now, since speed is equal to path length, what is path length? SI unit of path length is meter, time taken is second. Therefore, the SI unit for speed is meter per second. It is also sometimes described in terms of kilometers per hour. Now, let us look at velocity. What is velocity? It is again the rate at which an object changes its position. Now, velocity is a vector quantity. It is nothing but speed with direction, right? So it is a vector quantity. Since it is a vector quantity, so it is dependent on the vector quantity. What was the vector quantity? It was displacement. So velocity is equal to displacement divided by time taken. So the way there is a difference between displacement and distance, similarly there exists a difference between speed and velocity. Speed is a scalar quantity, velocity is a vector quantity. Speed is given by the total distance covered divided by time taken, and velocity is given by the total displacement divided by time taken. Let us take an example and understand speed and velocity clearly. Let us take the same example of the small boy. Let us suppose we have the small boy who is right now at rest at his home. Now let us look at this example. Let us suppose that the distance between the house and the McDonald's, this entire distance is 2 kilometers. So let us suppose this distance is 2 kilometers. Now this boy starts cycling. He starts from his home, reaches McDonald's, and then again takes a U-turn and comes back to his home. Right? The same story again. That maybe he missed his wallet and so he has to come back to his home. So in this case, what is the total? We will try to calculate the speed in this case. So what would be the speed in this case? Speed is nothing but the distance traveled divided by the time taken. So in this case, what is the distance traveled? Plus 2 kilometers while going, again 2 kilometers while coming back. So total distance traveled is 4 kilometers. Time taken, let us suppose that he took 1 hour to go to McDonald's and again he took 1 hour while coming back. So what is the total time taken? That is 1 plus 1, 2 hours. So it comes out to be 2 kilometers per hour. So 2 kilometers per hour is the total speed in this journey. So this journey included home to McDonald's and then again take a U-turn and come back to home. So in this case, what do we see? We see that the speed comes out to be 2 kilometers per hour. Right? Now let us look at the same thing in terms of the distance time graph. Now for the same scenario, let us try to plot the distance time graph. What is distance time graph? It is a graph where you plot distance along the y-axis and time along the x-axis. Now, what does this graph actually depict? It actually tells us how the distance varies with time. right? Now in this case, what do we see? The distance increases. That means the distance covered by the boy increases as the time increases, right? We saw that the speed came out to be 2 kilometers per hour, correct? So in 1 hour, this boy was gradually, traveling, covering some distance, and finally it covered some 2 kilometers in 1 hour. Correct? It is something like that. So in this case, if you plot this distance time graph, it comes out to be something like this. That is, the distance increases with time. So in this case, the slope of this line gives us the speed of the object, because when the distance increases linearly with time, that means as time increases, distance also increases proportionately. In that case, we will get a graph like this. That means when time is 1 second, distance covered is 1 meter. When time is 2 seconds, distance covered is 2 meters. Similarly, when time is 2 seconds, distance covered is 2 meters. Again, when time is 3 seconds, distance covered is 3 meters. So that is how we will get a straight line. So this kind of line we will get when equal distance is covered in equal intervals of time. Now, a plot of so this graph basically tells us how much distance is covered with respect to time. So slope of this line will give you the speed of the object. So slope of this line will tell you the speed of the body. Right? Now, how do you calculate the slope of a straight line? Slope of this straight line is given by tan theta. So in this case, the slope is given by tan theta. And how do you calculate this tan theta? It is nothing but, from this triangle, you can say that if this is A, this is B, and this is O. So from this triangle, you can say that tan theta is equal to AB divided by OB. Right? So let us look at the same example graphically. So in this case, we see that it covers 4 kilometers. Let us suppose this distance is given in kilometers and this time is given in hours. So from this graph, we see that it covers 4 kilometers in 4 hours, right? So AB is 4, OB is also 4, so it comes out to be 1 kilometer per hour. So this is the speed of the body. So in this case, we say that it covers 1 kilometer per hour, because in this case, they have considered that 2 kilometers is the distance between the home and the McDonald's. While going, it takes 2 hours. While coming back, it again takes 2 hours. That is what is the assumption in this scenario. So you understood how do we actually, what is speed? Speed is nothing but distance covered per unit time. So speed is equal to distance by time. So if you want to determine speed, you need the distance time graph. So from distance time graph, the slope of the graph gives the speed of the body. Right? So let us now talk about position time graphs. Well, I did not discuss much in detail about the slope of the graph, because that will be something which will be discussed in your mathematics. I'm sure that you have already learned about the slope of a straight line. Even if you have not learned about it, you will learn it in your mathematics lesson. So for now, you should only understand that the slope of a straight line is given by tan theta. So if you want, I can just tell it in brief here. So slope is given by tan theta. And what is tan theta? Tan theta is nothing but perpendicular divided by b. So this is the definition of tan theta. So tan theta is defined in a right angle triangle. So in that triangle, the ratio of the perpendicular to the base is known as, is what determines tan theta. So now that we have talked about distance time graph, let us talk about position time graph. Now, what is position time graph? Distance time graph tells us about the distance covered with respect to time. Position time graph will talk us about the position of the object with time. That means how the position is changing with time. Now, what is the difference between distance time graph and position time graph? Distance time graph talks about the path length or the distance. Position time graph talks about the displacement. It is not bothered about which exact path did the object follow. It is only bothered about the position of the object. That is what is displacement, right? Because displacement is only bothered about the initial position and final position. So that is why the graph which is plotted for displacement time is also known as position time graph. So let us take the same example. The boy starts from his home, goes to McDonald's, and then comes back to his home. So in this case, how would the plot look like? In case of distance time graph, how was the plot? It was like a straight line, right? Because the distance covered was irrespective of the direction, because the distance time graph was not dependent on direction. But in this case, direction also plays a role. So how will the graph look like? It will look somewhat like this. So here y-axis denotes position, x-axis denotes time. So what happens in this case? Initially, let us suppose the distance between the home and McDonald's is 2 kilometers. So time taken to reach McDonald's is 2 hours. Again, time taken to come back to home is 2 hours. Now for the first 2 hours, you see that the graph increases like this. That means the position increases with time. Now at this point, the position is at 2 kilometers and time is at 2 hours. So the position is at this point. Now as the position changes, when the position is 1 kilometer, maybe the position of the object is somewhere here. When it is 1.5, it is somewhere here. When it is 2, it is here. So this denotes the position of the object with increase in time. Now once it reaches this point, what happens? The object starts moving in the opposite direction. So since here we are talking about displacement, so direction plays a role because displacement is a vector quantity. So what will happen in this case? The direction gets reversed, and that is why again the position of the object changes with increase in time. So in this case also you see that as the time increases, the position of the object now again changed from 2 till 1.5, 1. That means earlier it was at 2, again from 2 it came to 1.5, it came to 1, it again came to 0.5, and then again it reached 0. So that is how the position of the object is changing, right? So when we plot the position time graph, it would be somewhat like this. But when we plotted the distance time graph, we were not bothered about the position of the object at each instant. We just wanted to know the total distance that has been covered. So that is why it was not dependent on direction. So now is it clear to you how did we plot the position time graph in this case? So the same scenario has been plotted in two different ways, because in one we are representing the distance versus time, and in the other we are representing the position versus time. Now let us see what does the slope of the position time graph depict. The slope of the distance time graph gave us speed. So now from our common sense we can say that on similar lines, the slope of this position time graph will give us velocity, because position is something which is dependent on direction, because position is nothing but the displacement we are talking about. So displacement is dependent on direction. Displacement is a vector quantity. That is why the slope of the graph of this graph, it will be nothing but velocity. So in this case, how do we calculate velocity? Here we actually have two straight lines. This is the first line and this is the second line. So what do we do? How do we calculate the slope? First we calculate the slope of this line, then we calculate the slope of this line. So the total slope will be slope of this plus slope of this. So what do we get here? So in this case, let us try to calculate the slope. Let me call this as line 1. This we call this as line 2. So slope of line 1 will be equal to tan theta. So tan theta, let me call this as theta 1. So this will be tan theta 1, which will be equal to perpendicular. This is the right angle triangle. So which is the perpendicular? This is the perpendicular. Which is the base? This is the base. So this will be 2 by 2, that is 1 kilometer per hour. So this is the slope of this line. Now on similar lines, let us try to calculate the slope of line 2. So slope of line 2 will be equal to tan of. So in this case, this will be tan of Which angle? This angle, because every time you should measure the angle from the same way. So this angle, so let me call this angle as theta 2. So this will be equal to minus tan of theta 2, because in this case the angle is in the opposite direction. Right, here theta 1 was measured from this axis. So here theta 2 should also be measured from this axis. So that means it comes out to be minus tan theta 2, because theta 2 will be nothing but, so here theta is nothing but this angle, that is 180 minus theta 2. It comes out to be minus tan theta 2. So this is equal to minus tan theta 2 will be P by B again. So this is again 2 and this distance is again 2. So this will be minus 2 by 2. That is equal to minus 1 kilometer per hour. So these are the two slopes. Therefore, what will be the net slope? So net slope will be equal to slope 1 plus slope 2. So that is equal to 1 minus 1, which is equal to 0. Therefore, the velocity is equal to 0 in this case. Now, why the velocity becomes 0 in this case? Now, we can prove the same thing non-graphically as well. So, hereby, with the help of the position time graph I showed you, the velocity becomes 0 in this. So, now let us look at what we have studied so far. We studied that what was velocity? Velocity is nothing but displacement per unit time. Now in this case, what is my displacement? The boy starts from home, he goes to McDonald's and again comes back to home. So my initial and final positions are the same. That is why displacement is equal to 0. So 0 upon time, that is equal to 0. So the velocity in this case is anyways equal to 0, because the displacement is 0, as the initial point and the final point is the same. So with this we will conclude our discussion on speed and velocity. So what all did we study in speed and velocity? Speed and velocity tells us about the rate of change of position of an object. That means how much distance an object covers with time. So when I talk of speed, it is the total distance covered in a specific amount of time. So it is a scalar quantity. When I talk of velocity, it is the rate of change of position with time. So it is given by displacement per unit time and it is a vector quantity. Now graphically, the slope of a distance time graph gives us speed and the slope of a position time graph gives us velocity. So with this, we will discuss about uniform and non-uniform motion. So what is uniform motion? A body is said to be in uniform motion if it covers equal distances in equal intervals of time. The term uniform means something which happens regularly, something which happens periodically. That is known as uniform, right? Something which happens on regular basis. So if an object covers equal distances in equal intervals of time, that means let us suppose there is one object which moves 1 kilometer in 1 hour. Again in next 1 hour it moved another 1 kilometer. Again in next 1 hour it moved another 1 kilometer. So that means in every equal interval of time, that is in every 1 hour, it is covering a distance of 1 kilometer. So we say that the object is in uniform motion. Let us take the example of this car. Okay, so now let us suppose you have a car running on a highway where where there is no obstruction at all. There is a smooth plain road where your car is moving. So in that case, your car might be moving at a uniform rate. That means for every 1 hour, it is covering the same distance. Let us suppose the speed of the car in this case is say 40 kilometers per hour. Now every hour, it is covering the same amount of distance. That means for every hour, it is covering 40 kilometers. After 1 hour, it covered 40 kilometers. After 2 hours, it covered 80 kilometers. After 3 hours, it covered 120 kilometers. That means every 1 hour, it is covering 40 kilometers. So that is known as uniform motion. So now, what is non-uniform motion? When I talk of non-uniform motion, I mean that a body is said to be in non-uniform motion if it covers unequal distances in equal intervals of time. That means it is something like, let us suppose if you have a car which covers 5 kilometers in first 1 hour. In the next 1 hour, it covered some 20 kilometers. In the third 1 hour, it covered some 1 kilometer. So that means for every equal interval of time, the distances which are covered are unequal. Sometimes the speed is more, sometimes it covers less distance, sometimes it covers more distance. So the best example for this is, let us suppose this orange car is your car and it is moving in traffic. So when your car is in the traffic, here you can see that there are two other cars just beside this car. So somehow it has to escape in between the space between the two cars. So therefore the speed of this car will be slow at this position. Then gradually when it reaches a little bit front, then he sees that there is a smooth road in front and it picks up its speed. So the speed increases. So here if you see, it is traveling slowly. It is covering less distance. Later it travels more distance per unit time. So that means when the amount of distance which is covered is unequal in equal intervals of time. So here you would have seen that in the initial 1 hour, it would have traveled say some 1 kilometer. The next 1 hour, it would have traveled some 15 kilometers. And in the third 1 hour, it would have traveled maybe some 25 kilometers. Right, because gradually the amount of distance covered is increasing. So this is known as non-uniform motion. So now let us look at interpretation from different distance time graphs. So just now I told you that by looking at the distance time graph, we get a lot of information not only about speed. I mean, as I mentioned, the slope of the distance time graph helps us to calculate speed of the object. So not only speed, but we will get many other information about motion of the object from the distance time graph. So let us look at some of the scenarios where by looking at the distance time graph, you have to tell, we can easily tell the motion of the object. So this is my first distance time graph. So we have distance along y-axis, time along x-axis. So what do you see? You see that as the time increases, the distance remains the same. The distance is 3 kilometers. Let us say it is in kilometers and this is in hours. So what do we see? We see that the distance covered is 3 kilometers for every interval of time. That means the distance is not increasing with time. The distance is constant with time. What does that mean? That means that there is no motion involved, because if the object is moving, in that case there will be some distance covered. The distance covered would increase with time. Correct? Let us suppose if the object starts from this point, he moved some 3 kilometers and reached here. Now, if the object is even now moving, then this 3 kilometers should increase to 4 kilometers or 5 kilometers or something, right? But here you see that with increase in time, the distance is always 3 kilometers. That means the object is at rest at this point. So that means it says that the object is at rest. So there is no motion involved. Let us look at the second scenario. So here we have a plot like this. So what do we see here? With increase in time, the distance also increases. So in the first 1 hour, how much is the distance covered? 1 kilometer. In the second 1 hour, so this is 1 hour. So in this 1 hour, how much is the distance covered? This much distance, that is 1 kilometer. Again after 1 hour, how much distance is covered? 1 kilometer, right? So that means in every 1 hour, the distance covered is 1 kilometer. So this is which kind of motion? That means equal distance is covered in every equal interval of time. So this graph depicts uniform motion. Correct? Because the object covers equal distances in equal intervals of time. Let us look at the third scenario where we have a graph like this. So here also, if you look at it very carefully, the distance increases with increase in time. Here if you see, your time increases. So the distance, when the time is 2 hours, your distance is 1 kilometer. When this time is 3 hours, your distance covered is 2 kilometers. and so on. So that means here also the distance is increasing with increase in time. But what does this show? That this line starts from here. What happens from this point to this point? That means what happens when the time varies from, or when the time increases from 0 to 1 hour. So in the first 1 hour, there is no movement of the object. So this is 0. So this is how the graph looks like. That means the object is at rest for the first 1 hour. After that, the object is in uniform motion. So only for the first 1 hour, the object is at rest, and after that it again covers equal distances in equal intervals of time. So it is in uniform motion. Now let us look at the fourth scenario where you see that you have a curved line for the distance time graph. So this is my distance, this is my time. So this is how the graph looks like here. So what kind of motion does the object have here? Here also, if you see, the distance increases with increase in time, but the distance does not increase linearly. If you see, in the first 1 hour, the distance increased from this point to this point. So this much is the distance covered in first 1 hour. Now in the next 1 hour, it increased from this point till this point. That means only this much distance. So if you see, this much distance in the second 1 hour and this much distance in the first 1 hour, right? Again in third 1 hour, if you see, the distance covered is more. This much distance is covered in the third 1 hour. That means for equal intervals of time, the distance covered is unequal. So this is non-uniform motion. Right? Because here you have a curved line like this. So it is not a straight line. Right? So because of this curved line, we say that the object has non-uniform motion. Now let us suppose if instead of this, you would have something like this, where you would have a straight line here, and then some curve and all here, and then a straight line here. This shows that this portion depicts uniform motion, right? This portion will depict non-uniform motion, and this portion will depict no motion, right? Because the distance remains same with time, so there is no motion at all. So this is how we can interpret about the motion of an object by looking at the distance time graphs or the position time graphs. Now let us talk about another important topic, that is average speed and average velocity. Till now we talked only about speed and velocity. Now let us see what is average speed. So now we will try to understand the significance of the term average. So when you have this word before average before speed, how does it make a difference? So let us try to see what is average speed as such. Average speed is a measure of the total distance covered in a given time. So normally, how did I define speed? Speed was nothing but the distance covered divided by time. Now when I say average speed, I am saying it is the total distance covered divided by time taken. Do you see much difference in the definition? There is not any significant difference as such in the definition. But you will understand the difference once I take an example. Now we will take two examples. One example of uniform motion, another example of non-uniform motion. Because when I consider the example of non-uniform motion, that is where you will understand the difference between average speed and speed at its best. So let us first take the simpler one, that is the example of uniform motion. Let us suppose this is a car which is covering equal distances in equal intervals of time, and therefore it is in uniform motion. So now let us suppose that this car covers 2 kilometers, or let us suppose it covers 20 kilometers in 1 hour. It started from this point A, it reached some point B. And the distance between A and B is 20 kilometers, and he covered this distance in 1 hour. So what would be the speed of this car? So the average speed of this car during its journey would be the total distance covered divided by the total time taken, that is 20 kilometers per hour. So this is the average speed of this car. Now, if I say what is the speed of the speed of the car is the same as the average speed of the car in this case, because the car is traveling, it is covering equal distances in equal interval of time. That means in every 1 hour, it is covering some 20 kilometers. Correct? So, because since it is moving in uniform motion, therefore we can say that the speed is nothing but it is the same as the average speed. But now let us suppose that, now in this case, if you plot a graph for uniform motion, it is somewhat like this. Now let us look at the example for a non-uniform motion. What happens in non-uniform motion? The speed of the vehicle varies. Like initially here, the speed of the vehicle was less. Then the speed of the vehicle increased little bit, and then the speed of the vehicle increased a lot. So that means the speed of the vehicle is changing from one point to another, right? So if the vehicle started moving from point A and it moved to some point B, right? Now in this entire journey, what is the average speed of the vehicle? So the average speed, because whenever we talk of average speed, we talk of the average speed for an entire journey. Now that in that journey, maybe the speed was different at during different points of time. So in this case also you can see that when I say the average speed for the entire journey, how would I calculate that? The total distance covered divided by the total time taken. Now let us suppose that the distance between this point A and this point B is 20 kilometers, right? And the time it took to reach from point A to point B is 1 hour. So what will be the total distance? That is 20 kilometers divided by 1 hour. So this is 20 kilometers per hour. So this is my average speed for the entire journey, right? But now at different instants of time, this vehicle had different velocities. For example, when the vehicle was at this position, that time it was crowded by two other vehicles. So it had a lesser speed. Maybe the speed of the vehicle at this point of time was 5 kilometers per hour. Then again, when it moved a little bit, maybe its speed increased a bit and it became 7 kilometers per hour. Then again, when the vehicle came somewhere around here and it saw that there was a smooth road in front, maybe its speed increased to some higher value, say 25 kilometers per hour, right? So what I'm trying to say is that during the entire journey, sometimes the speed of the vehicle was more, sometimes it was less, right? It was not uniform every time. Initially it was covering lesser distance for the same interval of time, but later it was covering more distances for the same interval of time. That means the speed for the vehicle at every instant of time was different. But when I talk of average speed, I am talking about the average speed for the entire journey. So when I say that the average speed of the vehicle is 20 kilometers per hour, that means that I don't know what was the speed of the vehicle at every instant of time. Maybe that was different. But if the vehicle would have traveled uniformly, that means if it would have covered equal distances in equal intervals of time, in that case, it would have covered 20 kilometers in every 1 hour, right? So now you understand the significance of average speed. Average speed tells us the speed or the average speed for the entire journey. Maybe the vehicle had different speeds at different instants of time, but then average speed for the whole journey is given by the total distance covered divided by the total time taken. Sometimes people do these kind of mistakes that, let us suppose, I will tell you with this example. Let us suppose that there is a car here. Suppose you have a car here. The car starts from point A, it goes to point B, and then it goes to point C. Now, when the car goes from point A to point B, the average speed of the car in going from A to B was 5 kilometers per hour. Again, it goes from B to C, and the average speed in going from B to C was 6 kilometers per hour. Now, what is the average speed for the entire journey from A to C? Sometimes people think that, okay, average speed for reaching from A to B was 5 km per hour. Average speed for reaching from B to C was 6 km per hour. So, average speed for reaching from A to C will be 5 plus 6, that is 11 km per hour. But that is not the case. So, that is a common mistake which people make, and please do not make the same mistake. Whenever you want to calculate the average speed, you should always calculate the total distance, then divide it by the total time taken for the entire journey. So in this case also, average speed will be the total distance AC divided by the total time taken to reach from A to C. Right? So this is the correct way of calculating the average speed. So now let us quickly talk about average and instantaneous speed. So now you understood, right, why we need two different terminologies for speed. One is average speed, one is instantaneous speed. Because in case of non-uniform motion, your speed keeps changing with every instant of time, right? So the average speed is the measure of the total distance covered in a given time, and instantaneous speed is the measure of distance covered at every instant of time. That means, in this case, as I mentioned, the speeds which it is having at every instant of time. At every instant of time, maybe it is having some different values of speed. So each of those values of speed at each instant of time is known as instantaneous speed, and average speed is the total distance divided by total time. So average, maybe there are several different values of speeds at each instant of time, but for the overall journey, you will have one value of average speed. Correct? So I hope I'm able to explain you what is average speed. Now on similar lines, we have something called as average velocity. The way we defined average speed, similarly we define average velocity as also. But the only difference is that in case of speed, we are talking about the distance covered. In case of velocity, we will talk about the displacement. So we will also talk about the direction in case of velocity. So when I talk of velocity, let us take this example again. Let us suppose we have this car, and this car travels some 10 kilometers in the east direction in 2 hours. So it travels 10 kilometers east in 2 hours. Now, irrespective of whether the velocity increases or decreases in between the journey, in between these 2 points A and B, whether the velocity increases or decreases in between, what would be the average velocity for the entire journey? It would be the total displacement divided by the time taken. So what is the total displacement? It is 10 kilometers. What is the total time? It is 2 hours. So this is 5 kilometers per hour in the east direction. So this is my velocity. So velocity will have direction associated to it, and velocity is related to the total displacement. Now let us look at this example where the car moves from point A to B and then again comes back from B to A. So it goes and then again it comes back to A. So in this case, what happens? What is the total displacement in this case? In this case, total displacement is equal to 0 because my starting point and ending point is the same. Therefore, in this case, the average velocity for the journey comes out to be 0. Right? So there is nothing much to explain in detail about average velocity again, because it is similar to average speed. So now you understood why we have this average and instantaneous thing separately for speeds and velocities, because the speed and velocity, they keep changing in case of non-uniform motion, and most of the motion which we see around us are all non-uniform motion. For example, when you go out in your car, does it happen that your car moves smooth all the time? Every time you cover equal distance in equal intervals of time? That doesn't happen. You have bumpers on the road. Sometimes you get other vehicles. Sometimes you are badly stuck in traffic. Sometimes you are on a smooth highway. So depending upon situations, your velocity or your speed will keep changing. And that is where you have non-uniform motion, and that is where you actually need two different terms. One is average speed and another is instantaneous speed. So on similar lines, let us quickly talk about average and instantaneous velocity. Average velocity means for the total journey, the total displacement covered by time. And instantaneous velocity is the measure of the displacement covered at every instant of time. Correct? That's what I explained before also. For example, in the case of this car also, maybe at this instant of time the velocity is 10 km per hour. Maybe at this instant of time it is 15 km per hour. Maybe at this instant it is 5 km per hour. So the instantaneous velocities are changing at every instance of time, but average velocity is the total displacement from starting point to ending point divided by the time taken. So the average velocity for the whole journey is, let us suppose if I say in this case that the average velocity in this case is 15 kilometers per hour. So I mean to say that if the car would have traveled without any hurdles in between, if it would have been a smooth ride for the car, then it would have been in uniform motion, and in that case it would have moved with a velocity of 15 km per hour. So that velocity is known as average velocity, right? So with this, I would conclude my discussion on speed and velocity with this small general example. So in this example again, we see that we have the same small boy standing near his home, and he wants to go to the church. So in this case, let us suppose the distance between the home and the church is 10 kilometers, and the time which the boy takes to reach from this home to church is 1 hour. So in this case, what would be the average speed and average velocity? So in this case, since the boy is going from the initial position to the final position via the shortest path, right? He will just straight away go like this without going any right, left or any curve turns, right? So in this case, my distance and displacement both are same, that is 10 kilometers. So what would be my average speed for the entire journey? Average speed would be total distance traveled divided by total time taken, that is 10 km per hour. What would be my average velocity? Average velocity will again be the total displacement, that is 10 km divided by 1 hour, which is 10 km per hour east, because maybe if we assume that this is my east direction, so it is going in the east direction, right? Now, what would be the instantaneous speed and instantaneous velocity? Instantaneous speed is like, if this is, he took 1 hour to reach here, maybe at when time is equal to 0, at t is equal to 0, he was here. At t is equal to, say, 10 minutes, he was at this point. So at this point, maybe he would have had some velocity v1. Again, when time was, say, 20 minutes, he would have some velocity v2. So these instantaneous values are nothing but instantaneous speeds and instantaneous velocities respectively, right?
I hope you found this video useful. Do let us know your feedback in the comment section. We will be eagerly waiting to hear from you. And I also hope that you found all these concepts very, very clear to you, because this is a very basic concept but a very, very important one. So I will see you all very soon in the next video, which is on acceleration. So stay tuned.